We now continue the previous problem. We found that the equation of our circle in standard form was x minus 4 squared plus y plus 2 squared equals 25. Now we just have to find the intercepts. The most important fact about an x-intercept is that y equals 0. The most important fact about a y-intercept is that x equals 0. So, to find an intercept, replace one of the variables with 0 and solve for the value of the other. Alright, let's find our x-intercepts by replacing y with 0. We'll have x minus 4 squared plus 0 plus 2 squared equals 25. Alright, 0 plus 2 is 2, and when you square it you get 4. Alright, subtracting 4 on both sides, we get x minus 4 squared equals 21. Now we're going to use the square root property from intermediate algebra. Drop the square in the parentheses. On the right, put plus or minus square root. Now add 4 to both sides, and we get x equals positive 4 plus or minus the square root of 21. Notice that this means there are two x-intercepts, one for the plus and one for the minus. So the first is 4 minus the square root of 21 for the x-coordinate. Of course, the y-coordinate is 0. And the other is 4 plus the square root of 21. This is the exact answer. If, however, a decimal approximation is desired, that can be computed using a calculator. I'm using the TI-30XS Multiview calculator. Alright, so let's put this in. 4, subtract, the subtract key is the one in dark gray over here on the right, square root, which is in green above the x squared key, so I have to green shift, then hit x squared, 21, enter. Now, if your calculator is set to give you exact values, then it's still going to give you a square root of 21 in the answer, but you can convert that to a decimal by hitting the double arrow button in the bottom right-hand side. When you do, it gives you the decimal approximation, negative 0.58 approximately. Using a similar approach for 4 plus the square root of 21, we get 8.58 approximately. All right, we will now repeat this process for the y-intercept by setting x equal to 0. Let's begin. So we'll get 0 minus 4 squared plus y plus 2 squared equals 25. All right, 0 minus 4 is negative 4, and when you square it, you get 16. Subtract 16 on both sides. Y plus 2 squared equals 9. Use the square root property from intermediate algebra. Y plus 2 equals plus or minus the square root of 9. Y plus 2 equals plus or minus 3. This represents two different values, one for the plus and one for the minus. Let's move the 2 to the other side. Y equals negative 2 plus or minus 3. So our first y-intercept is negative 2 minus 3, and our second is negative 2 plus 3. We get y equals negative 5, or y equals 1. Remember, both of these started off with the assumption that x equals 0, so this gives us our ordered pairs 0, negative 5, and 0, 1. This is the exact value. No decimal approximation is needed. All right, that finishes this problem, but before we call this done and move on, let's compare our intercepts to the graph and see how accurate we did. All right, so 0, negative 5, that would be right here. 1, 2, 3, 4, 5. Well, it looks like we got that one just right. 0, 1 is right here. Oh, look at that. That's good right there. That's some good circle accuracy. All right, Negative 0.58 is between 0 and negative 1. It's just a little bit of past the halfway mark. And that's pretty good as well. 8.58 is between 8 and 9, a little bit past the halfway mark. That one looks like we missed it by just a little bit. I think our circle was supposed to go up a little bit more and then come across. Didn't quite get that part correct. So you can see why it's very important to use algebra to find the intercepts, because your graph isn't always perfect.